welcome to part 7 of the CIDOS video development series. And in this video I decided I'd fed up with adding commands, and I wanted to do something where it's going to be pretty cool and more interesting. But we'll add the commands after this one. But in this video we're going to add the Cartridge Initiator routine. So we are building this as that it's going to pretend it's a cartridge, so you could burn it to an EEPROM and actually use it if you wanted to, and write the basic Tokenizer routine that's going to interpret what we type in and hopefully send it off to the right command and execute it. So since the last video I've added 2 more files, inc cartridge initiate and inc basic tokenizer. So in the cartridge initiate, basically what you have to do to it's a weird thing, because what happens is Commodore Basic, when you initialize it, the first thing it does is to test a string of characters, and it tests the string of characters from in the C64 terms 1004 onwards. And what it's testing for is these characters: capital C, capital B, capital M, 80. And what it does, if it finds those 5 characters in memory, it doesn't bother going to its own initialization system. It goes, oh, I found these 5 characters, so I need to find the initialization system for this system, which is called, in our terms, is called reset. And the first 2 bytes of the memory block is the reset. The second 2 bytes is when you do run, stop and restore. That's that command, and what it does, it takes note of those and then jumps to those locations. Now for the VIC-20, it's looking in 8000, so it's looking for capital C, capital B, capital M, A0, and it's exactly the same scenario. It looks at the first 4 bytes and then sets up the system. So in terms of a 64, we store X, which means that the screen always goes smaller before it comes back, yeah? And then we initialize the CIA systems, we initialize, we perform the RAM test, reset all the vectors, and then reset the screen editor and the VIC chip. Now for the next set, we copy the basic vectors from the ROM into RAM, which is basically copies all the vectors for hex 0300 up to 0320 something, and they are the jump vectors for basic. Then we initialize basic, and then we set the top of basic, and then we run the basic startup message, and we do the exact same for the VIC-20, which are these commands here. But with the VIC-20, we don't need to set the top of basic because it's at 8000, and before then is the video RAM, so we don't need to set the top of basic for the VIC-20. Then we set the stat pointer and transfer it into the system, and then we load our initialization memory, our initialization message, and then we perform our start before we jump to the actual MNI exit. Well, our MNI exit, which actually performs the proper MNI. Now MNI is slightly different because it's run, stop and restore, which means it's got to tidy everything up. So we run a couple of routines, like we check for the stop key, we reset the RS-232, we reset the RAM vectors, we initialize the CIA, we initialize the screen, we clear any channels, we perform a clear, and we put our message on the screen and restart the system, and then it does 0300, which is the normal MNI interrupt. Alright, so the text that we're going to show is the integrated disk operating system, and I put a little copyright here for me, and then we've done a VIC-20 version, but the VIC-20 has 22 columns, so we've had to sort of chop it down a bit, so it says the C equals size integrated DOS, and then 2 lines for the copyright. Now the start is just basically setting everything up, so we're setting all the basic pointers here, we're copying the basic vectors, and we do it again with the VIC, and then we're overriding some of the basic jump vectors. So we're going to be overriding what the terminology in the book is called cruncher. You know, we're overriding the cruncher vectors, but I prefer it to call it basic vectors. It's basically we're overriding the jump vector that evaluates the basic line, because we want to evaluate it first before we pass it on, and then we're going to change the jump vectors for the error message. So we're going to set the basic jump vectors, so I'll get that one and we'll put it there. That one. Put it there. Save that. And we're going to, so we're taking our tokenizer routine, so the start of the tokenizer routine, and we're going to store it into the basic jump vector. So we're effectively taking control of the interpreter of basic. So we're going to run it through our interpreter first before we hand it over to the basic interpreter. And then we just do a bit of a clear. So we clear out our DOS command buffer, we close the disk command channel just in case, reopen it for use, and we set all the basic top end stuff to make sure that we don't run into our machine code with the basic, because if you remember, basic stores all its string characters at the top and everything. And then we perform the new command. Well, that's the initializer, and that basically that will initialize the system. Now the tokenizer is a lot of jiggery pokery, black magic and all that jazz, but basically what it does is it runs through the keyboard buffer that is stored in 0200, and what it does, it tries to match the keys with the text with what we've got in our command structure. And if it finds one, it keeps testing the characters and testing the characters and testing the characters until in our command structure we go, that's the last character, and if we've matched our command characters with what's in the keyboard buffer, it goes, right, that means it must be that command, so we're going to run that command. And so what we do is, like I say, it loads it up, we check for spaces. If we've got a space, we ignore it. We get, if it's less than what we're testing for or equal to, then we jump around, and then what we do is we try to find the last character in the command list, because the command list is structured in such a way that the last character should always be shift the last character. So catalog would be catalog, but capital G right at the very end, and that's the way we let the tokenizer know that that's the end of that command string. And so we test it for the most significant bit and then carry on, and if it does find it, then it goes off to TK09 and says, right, I have found the command. We load the index, we times it by 2 because every run command's got 2 characters, 2 addresses because it's low and high, transfer it into X, and then we do command line +1 and command line address, and we store them onto the stack, and then we jump to get the next character. So when the next character routine does an RTS, it actually returns back to what we've put on the stack, which is the actual command. And then this is the reset, which resets the tokenizer ready to be sent back to the 64, because if we don't find our command, we have to reset it back to where it was, yeah, and then send it off to the Commodore BASIC. So that's what we do there. We reset it back, we tell it to get the next character, so we prime the next character ready, and then we jump to the original Commodore BASIC tokenizer routine, because we didn't find the command. And then the command list is just simply like this, like catalog, is little letters and then a capital G to say that's the end of that command string. We terminate the command string text but with a 0, because it does test for it up here. So if it's here, if it's equal to 0, then it jumps straight out. Yeah, jumps straight out. TK8 here. Right, and when it's found the command, it then looks for the command address, which is here, which is held in Word format. So what we're going to do is we've got all our commands loaded up, yeah, and so we're going to we'll run through them, yeah, and we'll start with catalog, which is there, and we've included now our cartridge initiate, which has got to be the first machine code that it gets assembled, and then we've included the tokenizer. So what we're going to do is, in the tokenizer, we're going to activate this and activate, well, in fact, no, we're not. I'm going to show you it working. So we go in here, project, program. Now what's going to happen is there should be nothing happening whatsoever, yeah, because we have not put any commands in, so it should not find anything, so it should go straight to the 64 BASIC. So we've loaded it in, and what we're going to do is we're going to do a soft reset. We're not going to do a hard reset because that clears all memory out. We're going to do a soft reset. There you go, Commodore 64 BASIC, 64K RAM. You notice the basic number of bytes available in BASIC's gone down because we set the top end of BASIC. And then we've got our message, which is the integrated disk operating system, CIDOS, blah blah blah. Now I don't like this extra line, so what we're going to do is we'll change the message on the initiator. And I think we've got an extra return in there, so we'll get rid of that, and we'll get rid of it there as well, because that's the same. So we'll do the set. We'll go back into it. Whoops, I don't think I hit it. Go back into it. There we go. So we'll do a soft reset. There you go, the basic number of bytes have gone down, and here we go. And now we've got a better thing. So we should be able to still write our program. There you go. Should be able to still list. There it is. Should be able to still run. Excellent. But if we try to do catalog, won't find it because we haven't put it in. So we've what's happening now is that every time we press enter, instead of it going straight to the 64 tokenizer, or cruncher as they call it, it goes to ours. evaluates the text, doesn't find anything, then sends it on to the standard interpreter. So what we're going to do now, and I'll show you what happens when you do run, stop and restore. So if we run, stop and restore, there you go. So it's just basically resets everything. So we're going to activate catalog now. So I've activated the text for catalog, which is CATAOLG, and the where it's located, and we'll build it again. There we go. Now get it to do a reset because we need it to initiate. There we go. So now we should be able to type in catalog, and there you go. How cool is that? So if we put true drive emulation on and add our disk image, so catalog, there you go. And we also, it should be C/Shift-A. There you go. How cool is that? C-A-T. Yeah, even that works as well. So we've got one of our commands working. So let's put some more in. So the next one is going, let's say we're going to do status. Now status was the address status. Okay, so what we do is put here text status, capital S, because that's the identifier for it to finish, and then we put in here word status -1. And the reason why I put -1 is because with a go sub, when you put it on the stack, it actually puts the address of the address -1 onto the stack. So when it brings it back, it says I've got to advance. It advances the program counter one address point, and so we have to put it on the stack with -1 on it, or it won't run to it. So we'll save that, go back to CIDOS, build program, and so now we should have the next command called status. So I'll reset it. So status. Ooh, file open error. Boo, hiss, boo. Okie dokie. Now, what's the problem with that? Is it because we open? Yes, we open the disk. Right. So what we need to do, we don't need to open these, because we decided to open them as we perform the task. So we don't need to have the channel open all the time. So go back into it. Sorry if you can hear anything in the background, but it's absolutely tipping it down outside. Typical British weather. Right, here we go. Soft reset. Bring our system into play. Status. Hey, here we go. Right, we'll make it do emulation, so we get it to error. S, capital Shift T. Should get an error. Yeah, read error. There you go. And so it's a case of just adding all the commands in that we've done. Right, next one. Let's have a look. What's the next one? Status, initialize. Right, so go to the Tokenizer. Initialize, that's the start point. So go into the Tokenizer, add a new keyword, initialize, make it a capital E, and then add the address. And this. Okay, do reset. So, initialize. Yes. And have you noticed we've still left the debugging thing in there because I just want to make sure it is before we turn we turn it off. Get your teeth in, John. Right. So what I'm going to do is I'm going to put all the commands in, and I'm going to carry on recording, but I might just speed it up just to make it a bit more interesting for you, and then we'll come back to what we've got and see if everything works. So I'll talk to you in a minute when I've loaded everything up. See you later. Right then, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 commands in at the moment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've put all 10 commands that we've written so far into our interpreter or tokenizer. So let's see if everything works. Here we go. Well, it compiled, so now the first one I'm going to try is device, because remember we had a problem with that. So press device, tells us current device is 8. So device is 9. Press enter. Device not present. That would be right. Task disk image to 9. Right, device is 9, and it's complaining about being open. So okay, device 8. So we need to sort out that problem. Close 15, I think it is. Right, device is 8. So device 9. Are we not closing it down? Let's have a look. Need to look at the device. So we go it, we do it, we jump to status. So status, do that, and then we jump to DOS. Well, we know what DOS is. So DOS. We open the channel. And then I bet this is where the error is. Show the DOS command. because we close it here. But do we close it anywhere else? Status, right, status, because it jumps to status. It says already open. I bet let's just do that. I want to do that again. So we're not doing scratch, we're doing device. Right. I think we're just getting a bit confused with our files being open. So do the soft reset. Do device, and it's doing it. Then it goes to the status because it's coming back with OK. So device again. So that's all right. So when we do device 9, it's coming back with device not present. Device 10, device 11, device 12, that shouldn't be allowed, device 13, legal device number, yeah, 12's not allowed, 8, 9, 10, 11, I don't think 12's allowed, device 7, yeah, device 8, file opener. So it's saying that the file's open because the status is trying to run. So when we do, so first of all, right, device 12 is the biggest one, greater than 12. And it's greater than or equal 11. So we open the channel. We load the device text, yeah, that's alright. So we open the command channel here. Why are we opening the command channel? Well, we're not sending it anything, are we? Load the device number. That's alright. Jump to status. Yeah, we don't need to open the command channel. That's what's happening here. So we're opening the command channel again. Right, okay, here we go. I think that should have sorted it. Right, reset. Soft. Device. Should be on 8, yep. Device 9. There's no such thing, so it should come back with an error. There we go. So if we go back to device 8, we should be okay. Hey! Right. Let's load device 9 with something. There we go. Change it to device 9. Beautiful. Right. So, new 10 print test 20 print test again. Right, so we've written the program. Chain. So we're on device 9. JCD test. We're on device 9. We don't need to put the command in. So press enter. Here we go. Catalog. JCD test. Excellent. So that's chain. So we're going to do rename. So rename JCD test to test. Are you sure? Yes, we are. Catalog. Ha! Love it, love it, love it, love it, love it. Right, copy, test, to, test, to. Yes, we are sure. File not found? Really? File not found. Why has it come up with file not found, but it's still put it there? Load. Test 2. Come on 9. Well, it's there. File not found. We'll have to have a look at the copy command and see why it's coming with file not found. We'll do that again. Copy. Test. Test. 2. Test 3. Yep. Ooh. Okay. Scratch. Test 3. Yep. One file scratch. Catalog. Hey. What else we got? Oh yeah. Collect. Yep. Done. We've tested and initialize. Header. Okay. Header. So header. So format test 2. And we want the ID format 2. On the drive 8, yes. Drive 9, sorry. Done. Catalog. Love it. Right then, so that's the Tokenizer and the cartridge. Yeah, it's still there. Catalog. And the cartridge initializer. So the next video we'll be adding some more commands in, because we're going to add the SD to IEC commands as what in here as well to get them done. And so I will see you on the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.